Welcome to GasPal introductory tutorial. In this tutorial we will demonstrate how you can quickly build a model with a single reservoir that has two wells and two layers and a simple surface network with one terminal or delivery point. In GasPal main window, we will start the project by clicking the New File, New Project icon on the toolbar. We'll change the project name to Tutorial 1, for example. We will leave the default maximum number of reservoirs, compressors, and terminal node tables. We will modify the base time, basically the time where the simulation starts. We'll start the simulation in January 1st of 2009, and we will keep our project with English units. Once we click OK, we see a default reservoir appearing on the screen. That default reservoir originally has a single layer and a single cell. Since we said that we'll have two wells in our reservoir, we will model those two wells by two cells. So we'll start by adding an additional cell to our reservoir. We do that by right-clicking the reservoir icon and selecting the number of cells options, and we'll increase it to 2 and save our changes. And now we see that in the project tree we have our new reservoir that now contains two different cells. Since our model, we want to have a reservoir that has three different layers, we'll change the number of layers of our reservoir, and we'll change them from 1 to 3. So now we see that each of our cells in our reservoir contains 3 layers. In building our reservoir model is to change or edit the basic properties of the reservoir. So we will, for example, change the name of the reservoir to Res1. We will maintain the surface temperature and reservoir temperature and rock and water properties by the default values, and we will also leave the default values for the inflow calculation, the minimum cutoff rate, the water rate model, and the condensate rate model. As you can see, GasPal has several options that you can use to model your reservoir. We will start with the more basic options. Next, we will introduce some connectivity between the two cells in the reservoir by putting a non-zero value for the interregional flow coefficient. We'll start with a value of 1, and the next thing we will do is we'll modify the relative permeability curve. Since our water model is a standard Darcy model, the water mobility will depend on the relative permeability curve. So we'll modify the relative permeability curve a little bit to make water a little bit easier to displace. For example, we introduce these two values and we see how the green curve, which is the water relative permeability curve, we'll see that makes water a little bit more movable in that sense. The next feature that we want to demonstrate is to connect an aquifer to one of the cells in our reservoir. So we open the reservoir data input window again, and we select the aquifer tab, and we will select a single layer aquifer. We will modify some of its properties. For example, we'll make a depth of 6,000 feet, a pressure of 3,500 psi to be in accordance to the depth of our cells, and we will connect that aquifer only to one of the layers one of the cells in our reservoir. So we'll connect it to all layers in our cell 1 in our reservoir. We'll start by giving it the strength of the connectivity between the reservoir and the cell of a value of 0.5. As you can see, now the cell 1 of the reservoir has a light blue frame showing that there is a aquifer connected to that cell and each of the layers on that cell. So next thing we'll need to do is to modify the cell properties. Remember that in GasPal, a cell is typically associated as a well. So this is basically like inputting all the well properties. So we'll define our reference pressure at 6,000 feet. We will enter the GIP for each cell. For example, for cell 1 we enter 100 VCFs. Next we proceed on changing the tubing properties. We will also enter a length of 6,000 feet, an elevation of 6,000 feet, making it a completely vertical well. And we will leave the gray modify as the pressure drop correlation. Next thing we need to do is define a well schedule. So we will, for example, define that we will drill a well every other year for the first 5 years of our simulations. We just do that by entering the number of incremental wells in this time vector. And the next thing we need to do is to modify the layer data. So for example, we will leave the permeability of each layer at 5 millidarcies. We will change the height of the layer to 300 feet. We'll change the pressure accordingly and depth of each of the layers according to our model. So once we've modified the properties of cell 1, we will have to go and modify the properties of cell 2. That we will probably increase a little bit the permeability in this cell. We will maintain the same cell height. Pressure. And depth.